In this video, we're going to look at a compound inequality, and we want to find the solution set and graph that solution set on a number line. So this is a compound inequality because we have three different regions. We have the -6, the 1/2 x minus 4, and the -3 occupying those three regions. So we have two inequalities in this particular situation. And so what you want to do in a problem like this, you're always going to have a variable, and it's going to start out in the center of those two inequalities, or in the middle region. And what you want to do is you want to isolate that variable and get it completely by itself in that inner region. And so what we're going to do is we're just going to perform different types of algebra, adding, subtracting, multiplying, or dividing, in an effort to get that x by itself. But whatever we do, instead of to one side, we do to the other. Now in a problem like this, anything we do in the middle region, we have to do in both of the outer regions as well. So our first step in getting the x by itself, or unraveling the puzzle, is to add 4, because that's going to cause the -4 to cancel out. But again, whatever we do in the middle, we have to do on both sides. So adding 4 all around, -6 plus 4 is going to give us -2. It's less than or equal to 1/2 x. Less than -3 plus 4 is going to give us 1. And so now the x is being multiplied by 2, so what we can do, multiplied by 1/2, so what we can do is we can divide by 1/2, or that's the same thing as multiplying by 2. So we're going to multiply all the regions by 2, do the 1 times 2, and do the 1/2 x multiplied by 2 as well, because the 2 is going to cancel out that 1/2. So 2 times -2 is going to give us -4, less than or equal to, the 2 and the 1/2 are going to destroy each other, leaving just x in the middle region. Less than 1 times 2 is going to give us 2. And so now we have -4 is less than or equal to x is less than 2. So that's going to be our most simplified form of this compound inequality. So we've quote-unquote solved it at this point. So now we need to turn this compound inequality into interval notation solution set, and then ultimately we're going to graph it. So the x is in between the numbers -4 and 2. So that means it's going to be any of the numbers between -4 and 2 are going to be potential solutions. Now, as with any time we're working with an inequality, we have to worry about whether it's, in this case, less than or equal to, or just strictly less than. If we have the equal to bar, we're going to need a bracket. If we don't have the equal to bar, then we're going to be dealing with a parenthesis. So the smallest number that we're going to have in our interval is going to be -4, and we're going to include that because we do have that less than or equal to bar. And we want all the numbers between -4 and 2. And with the 2, we're going to do a parenthesis. And that comes from the fact that we don't have the equal to bar underneath that inequality. So our interval notation solution set is going to be -4 to 2, including the -4. So let's go ahead and graph that on a number line. We can put 0 in the center. And if you want to count out your tick marks, so 1, 2, go ahead and make note of that. -1, -2, -3, -4, make note of that. And we want all the numbers between -4 and 2, including this -4. So we're going to go ahead and do the bracket or a closed circle around the 4. And we're going to do a parenthesis or an open circle around the 2. And we're going to shade all the numbers in between. And so here is our answer in interval notation, and here is our answer graphed on a number line. So the main thing to remember here is you have three different regions if you have a compound inequality. So whatever you do to one region, you have to do it to all three of those regions. And ideally, you just want to get the x by itself in the center region, then interpret.